And we are going to proceed with the birth of a feather session on reproducibility in astronomy. And it works on my laptop.
So welcome to this BOF session. So it has a very long title officially, but what I would just like to call it is reproducibility in astronomy. And I think it's a fairly important subject. It's a very important subject. So it's only me on the panel. So what I would like to encourage everyone to ask questions. It's designed so I've got slides, but it's designed in the way so that we can have as much as possible through Zoom a conversation that we can exchange ideas, because I think it's a very, very important subject, reproducibility, and indirectly and directly it's coming up in talks and in BOFs that we've already had and will have. If you look at the list of BOFs, there is a lot of about citations, archiving data, standardization of data, data formats, that all works in tandem really with reproducibility, and all these things together sort of ensure reproducibility, make reproducibility easier. So this is more of like an overarching BOF of how we approach the reproducibility and how to go around it really. So as I said, it's very important. So I encourage everyone to be active in the discussion. Please ask questions. I'm monitoring. I'm lucky to have two screens. So I've got presentation on one, and I'm monitoring Discord and all the lists inside. So please feel free to ask away, ask all the questions, raise your hands, and I encourage everyone to ask questions. So there are no silly questions, there are no stupid questions. If you've got a question, please ask. If you see something that you disagree with, raise your hand, say that you disagree, or in questions panel, say that you disagree. If there is something that you really resonates with you agree, do the same. So please be an active participant. So it's a long word, reproducibility, and I bet there is somewhere on the slide that I misspelled it. But what does it actually mean? So before we actually start talking about reproducibility, we need to really talk about what it means. And over the last few years, when I get really interested in the subject, I've started talking to people, and I started talking. The main question is, what does reproducibility mean to you? And you answer multiple people, you answer 10 people, and then you don't get the reproducible answer. See, it's a difficult word. And the most common theme is it will depend on the field. So depending where you're coming from, the reproducibility will mean something else for you. Might depend on your personal preferences. So often there is a situation that even within the same field or in the same working group, you've got people with different experiences. Someone could have been developing code for 30 years. Someone could have been working on the code for 2 years, and someone might be just came from finishing undergrad degree, person who's never done any code before, and starting, to write first lines of code in Python or any other language for the master's thesis, or or PhD. So for each of these personal reproducibility may mean something else, but it also may, well, kind of connected to the field, but depending where you are in the processing chain, and we see by the already talks given, we've got a range of people attending the conference. So we've got people what I would like to call from all the areas of the processing chain. If you build hardware, reproducibility may mean something else, and you might have different criteria for reproducibility. If you build an LNA, for example, if you pass some signal for your NLA, you want to get an output within certain limits every time you pass the same input. Do you write software or manage software? As a software manager, reproducibility may mean something else to you than when you write software. Or are you the person that runs the experiment, who points the telescope and looks at the data and collects the data, and ultimately reduces the data, processes the data? Reproducibility may mean something else to you. So as I say, your mileage may vary. So first call to all the people listening is I would like to hear what reproducibility means to you, and which fields are you coming from, and are there any sort of requirements imposed by your field on the value of reproducibility? Because there are certain fields that may have some of the requirements slightly to a lesser extent than others. So why do we really need reproducibility? And it's kind of an obvious question with an obvious answer, so that we can really repeat the experiments and reproduce the experiment, reproduce the results. So reproducibility is so that we can reproduce the results. It's a closed circle in this case. But again, it's very connected to I think the first slide, to what it actually means to you. Will dictate what you need it for. So if I'm a software administrator and a software manager, my meaning of reproducibility might be that I've got a nice package ecosystem, and every time I deploy it on a new node or have to reinstall the node, I've got the reproducibility. I can reproduce the software ecosystem on every node, on every compute node, independent, in short amount of time with as little downtime as possible. And every time I do it, it's ensured that it's exactly the same most of the time. And I need it because I know that I've got users that I have to provide for, that someone depends on this code. If you are a scientist that produces the data, that produces the results, yes, it's even hard to reproduce the word reproducibility. I've been saying it so many times, and I still can't. There is even worse word coming up later. So if you're a scientist, reproducibility might mean something else to you. That maybe every time you run the pipeline, you get at least similar results, and so on. There is also one part of why we need reproducibility that I think is is often not neglected, but put to one side. But I think as time goes by, we should be more and more aware of. And that is maybe geared towards mainly software developers and scientists, is, we've had a lot of talk about the citizen science projects in previous sessions, but with the availability of data, we've got more and more sort of citizen scientists that want to get involved and do get involved with the data, and we have to keep that in mind as well. That especially in this day and age, we've seen over the last few years that it's also very easy to become an expert on a subject by just reading a couple of blog posts, and then it's fairly easy to undermine someone's research. So we have to keep that in mind, that we also have a duty to provide good software description, good data, that if someone wants to run something as a citizen scientist, that it's also easy for them to reach the conclusions that we have reached, and make it more difficult to come to wrong conclusions. Right. I see there's some people writing stuff. So how do we achieve reproducibility? And it's sort of, it's going to come over there will be a couple of slides connected to it, but one of the things that come up in discussions is, again, connected to the previous slide, is what do you expect from reproducibility? Is, well, how much reproducibility do you need? How much reproducibility is enough reproducibility for you? And is 100% reproducibility even possible? So I've spoken to people that for them it's enough to run the experiment and run a simulation and get a result, and get the result within a certain, with a certain sigma. You repeat the simulation, you will get some different results every time you run it. They understand it, but that's expected for them. For them, it's just a thing of writing a paper is to clearly communicate it. But on the other hand, I've spoken to people that they expect, when they run the code, that whenever they run the code, they get answer exactly the same every time, no matter what hardware they run it on, no matter, well, software stack. That's kind of an obvious thing, that you might get differences there, but mainly no matter what hardware they run it on. I've spoken to a person that wanted their code to give exactly the same result, run on a CPU and on the GPU, and this is a very, very, and their requirement was especially pretty much down to a single bit to have exactly the same results, which if anyone has done any parallel computing will know that it's very difficult, if not impossible, to achieve. But there are people who see reproducibility like that they really want to have a 100%, the same results every time when they run their experiments, when they run the piece of software. They can't compromise. So yeah, as Peter commented here, even between running on N processors on OpenMP, you will get different results. Yes, and that is a common thing in programming. When you're operating, on floating point numbers, A plus B plus C does not mean equal to B plus C plus A. That's that's just the nature of how these things operate. And the more parallel you become, the more obvious that becomes. I run into that trap multiple times myself when I just forgotten that I'm, how can you forget that you're working on floating point numbers, but you just check whether some results equals to the given number, and even running a summation simple sum on NumPy, and running then the same sum, technically the same sum on a GPU, can give you a result slightly different to like 6 decimal place on a 6 decimal place. So for me, for example, that would be acceptable. For me, that's a reproducible result. But for some people, that's just unacceptable. And yes, I see a comment that expecting identical outcomes on different hardware architectures shows a lack of domain knowledge. Does it not? Yes, I would say so, but as I said, that's again just my opinion, and some people would disagree. Well, as I said, I've spoken to people that would disagree, that they just understand that they think it's just write it code more carefully. But yeah, I think that might just come to this sort of yes. I think that there might be a bit of an ego, or as you said, it's just a lack of fundamental understanding of what's going on, and surprisingly, it's that was mainly, as I said, your experience, your mileage may vary. That surprisingly didn't come from scientists turned software engineers, or observational scientists turned software engineers. That very often, to my surprise, comes from people that either did some computer science related degrees, or have been in software engineering most of their career. Yes, I see someone, Thomas, raising the hand. I don't know, because I don't have a participant yet. Okay. Yes, Thomas.
Yes, I'm on now. Yeah, I'm the guilty party who.
Mateusz, you can, as co-host, you can promote anybody, especially the one who raise their hand, so you see them in the list of attendees.
Yeah, I cannot see the list. I don't have access to participant list. It once I was made a co-host, it disappeared.
You co-host,
for some
and
reason.
then you can show the list of participants. So now we have.
Goodness, has that disappeared? No, I cannot see the list of participants.
Hi,
unfortunately.
can you see the list of participants? There are two panels, one for the panelists and one for the attendees.
So
no.
Thomas Lopez has raised his hand.
No, I cannot see the list of participants. I was wondering about it.
Okay, I can be in charge of that, of giving
that would
people
be great. Thank you.
the right to talk. Okay.
Thank you. Sorry about that. Yeah,
and Carla is going to promote Thomas as panelist.
Yes, you did. Thank you very much. I'm the guilty party who sent that comment on Discord about the lack of domain knowledge. Well,
I think it's a good comment.
Isn't it one part of our education, the scientific education, that we learn to, say, there my domain knowledge ends, and I don't understand really why it's not reproducible. Let's call in the cavalry. right? Let's call in the professionals. Hey, Mateusz, you do GPU number crunching all day long. So why is my result not reproducible on your hardware? Why is it only reproducible on my tiny laptop, and your big ion can't reproduce this simple result? So why don't we ask that question? What's your take there?
Yeah, I don't know. I think that one thing I will talk about. I think, you know, you touched on that, upon, you know, how we are taught how to do it. A lot of, you know, a lot of us maybe come from backgrounds that yeah, we are, you know, observational astronomers turned you know, software engineers, and a lot of this stuff is you know, when I was, say, taught programming at university, there were very basic courses. You know, there was stuff taught along the lines of, oh, you know, you tell computer what to do, it does it exactly how to do it, or phrases like, okay, you can express any number you want exactly, or any number you want as a binary representation. So maybe it comes a bit to that, you know, the lack of understanding, and you know, I personally, if I knew that something was broken, or if I didn't understand, I knew that I would ask someone. Maybe it is the problem that people don't understand that there is a problem. I don't know if that's clear. Or maybe, you know, I'm just too hopeful and too naive that I would believe that, you know, whenever people don't understand something and see that there is something wrong, that they would ask a question, and they don't really do that. But at least I hope that partially it is the case that you know, it's still not well understood that there are problems, and
yep.
And yeah.
But Mateusz, look, just a year ago, I worked for Astron, right, within for the LOFA telescope, and well, we had to update our very simple basic pipeline, one of our pipelines from to C++11, right? And so I took the task and updated everything and made the code compile and just run fine and prepared the Docker images, and then we just fed some simple data to it, right? And then the data came out, and the result was that it was not bit identical. Yeah. Just by switching a compiler from C++98 to C++11, yes, right? Yeah. And having to update the compiler, having to update the Linux distribution, because the compiler wasn't available for the old distribution. So a very long story cut short. That was the moment when I thought, this is something I have no clue about. I better call in help, because boy, this is not something I would have expected. You know, yeah. Because I'm naive, like you described, right? I didn't get fed the numerical recipes with a spoon. So to me, that was quite surprising. But well, yeah, that was the moment of enlightenment where I said, yeah, well, now it's time to ask my colleague Mattia Mancini, who actually took on and trying to explain that to me and others. And so we worked out then a process where we could actually compare the results. And they took a long time to explain that to me with standard deviations and all that, numerical noise and all these things. And that gave me a great understanding. So there's something to gain, right, by asking others.
Yeah, no, I personally, you know, I definitely agree. And when I see the problem, you know, as you said, we don't know it all, and then yeah, we definitely don't know it all, because it's all such a complex. Everything is so complex these days, but you know, I unfortunately I don't think, you know, as you said, you know, based on everything that you said, and what are we talking about here? Unfortunately, there is no think, concrete answer to that, because that will just depend on the person. You know, as you said, you know, there will be factors of, you know, personal preference, personal sort of beliefs, and unfortunately ego. You know, all of us, no matter how much we say that we don't, we all have, you know, our own pride, and unfortunately sometimes that prevents us, you know, from either asking questions or thinking, oh, you know, I can do it on my own. I can figure it out on my own. You know, I've got a PhD, I've got a master's degree, or I've been writing software for 30 years or whatnot.
Yes,
you know,
I
a lot of us
agree.
think I can do it on my own, you know.
I absolutely agree. I'm in many of the categories that you just described, and pride is the number one on my list. Of course, I'm proud of what I'm able to do and all these things. But isn't that then that we're asking the wrong question, right? Shouldn't we be surprised that the results are reproducible? Shouldn't we expect then? Should then the basic expectation not be, okay, my results are not reproducible. Why are they?
Well, as I said, it's I think it's again back to you know, I think we are coming back to what we mean by reproducibility, because for everyone else that will be a different meaning. Because as I said, for an engineer, a reproducible result might be something different to, you know, someone expecting, you know, an exactly bitwise reproducibility, which, you know, I asked this question, you know, is 100% reproducibility even possible? And my opinion is, if we mean that by reproducibility, you know, exactly 0 and 1, zeros and ones, exact sequence zeros and ones every time you run the experiment, then you know, I think as what you said, yes, then we can't have reproducibility, and then the whole idea of reproducibility is thrown out of the window, because by the very definition, you really can't have reproducibility in this sense. Yes, as you said, you know, you sat down with your colleague, you understood, you know, that there are, you know, equations that tell you, you know, error rates and everything, depending, you know, especially on floating point operations. Then it's the sort of, you know, as much, then I would put it to as much as reproducibility as possible, with an explanation of why don't you have 100% reproducibility. And then I would still count that, you know, as a reproducible result of, you know, is not 100% the same streams of 0 and 1s, but clear explanation of why it's not exactly the same. So I think, you know, then that would count as reproducibility, because you know, I'm in the camp that does not, that, you know, would not count the, as I said again, the bitwise hardware reproducibility, strict hardware reproducibility as you know, a cornerstone and as a necessary thing for absolute reproducibility.
So that connects nicely to Kai's talk yesterday, right? If we know the uncertainties, if the uncertainties are certain, yes, which means we have the means and the knowledge to explain them, then reproducibility becomes a much better defined subject.
Yes, yeah. I mean, and you know, it's not only. I think, you know, with uncertainty, it goes down to you know, how many people understand science, even us as scientists, that, you know, certain things are stated as facts, and with uncertainties either, you know, swept under the rug or pretty much, you know, not taken into account or not explained clearly. So I think, you know, yes, that should be an essential part, taking these into account and making sure that we, you know, communicate them better. Okay, I see we've got more people joining the discussion. Yes.
Hello.
Hi, can you hear me?
Yes, yeah.
So one important aspect, I think, is unit testing of software. So that's a relatively easy approach, I would say, with PyDat-test if you code in Python. And I've heard good suggestion to first write a unit test and then write the real function we were thinking about, and do it every time you basically write a function. Thank you.
Can you hear me?
Yeah. So this is one of the things. Well, I think that there is on later slides. So I think we can have a more detailed discussions about how we can actually achieve that. I think sort of maybe it's it's a wrong title slide, but I think it will be later. Yes, I agree that unit tests are important, that testing is very important. I hold a slightly controversial view of unit tests. You say write unit tests first and write a function. I'm of the view of the same people that write a function should not write a unit test for it. And I've been told of many times for it, but I stick with that. I've seen many examples that when that goes wrong, that the person that writes a unit test writes a function as well, and then stuff goes wrong. Yeah, I think Susanna wants to.
If you have human resources, then of course people.
That goes back to human resources. Yeah, but I think, as I said, there will be place to talk about, I think, unit tests later in the detail, so we can come back to that. I know. Sorry, Susanna, can I give the floor to Samuel first, because he's been waiting for a while.
Can you hear me?
Can you hear me?
Yes, Samuel, I can hear you.
Yeah. Before I say my comments, just a quick comment on unit testing. You said you come back to it, but I think that for the subject of reproducibility, unit testing, where it's very strong, is just to give you confidence that your piece of code or solution works the way you intend for it to work, but not necessarily to reproduce the results that your solution brings. Well, to my comment on Discord, my frustration with reproducibility, of at least from my experience so far, has not been really with the results to say that is it exactly as what you get when you run your code, but it's been to even run the code and have it run the same way it ran on your environment. And that has been my frustration. So somebody has a piece of solution, a piece of code, they share it, whether from a colleague or from a paper or whatever, and you get that solution, you try and have it just run in your environment, and that never gets to run. So resolving that first, even that to have a reproducible in the same way on someone's machine as yours before you even compare the results, I find that also very frustrating. And things like containers can be useful for that.
So we will talk about it, like the tools that we have for reproducibility. But one thing, for unit tests, you can see it as the way, I think we've already talked about it before. When you've got a unit test, you can run it on different machines, different hardwares, and when you get results, when you get results from your unit test, you can I can envision it, being useful to compare on other things, but I think one thing is we do underuse and underappreciate unit tests, definitely, and there is I think greater scope for using them in whether it's software engineering or just general science. Susanna, sorry to keep you waiting. I know you tried talking a few times.
Hello, can you hear me?
Hello. Yes, I can hear you loud and clear.
Thanks. I just wanted to make a comment related with reproducibility, and something important is that we need to take care of scientific reproducibility, which means that because it's a basic in the scientific method, So if a study is not reproducible, it's not a science, no? So we need to take care of that, and this means that, and this is something that gives us a definition of what reproducibility means. So we know from many years ago that scientific reproducibility means that an external group, a different person can get the same results of a scientific study, maybe using your same data, using your same method, but the scientific result achieved is the same. So maybe when you talk about to get exactly the same results, exactly the same values of after running a pipeline, we are talking about repeatability of the experiment. But maybe this not mean that the experiment is not reproducible if you don't get the same exactly values for your results, because maybe this not change your scientific results. I mean, maybe that depends not only of the field but the experiment itself. If you run your pipeline in a different platform and you get different results, but the scientific result, it doesn't change, your scientific experiment is still reproducible. So we need to take care how to achieve scientific reproducibility, which I think this is an important thing, because it's what differentiates what is science from what is not science. And for this, we need many things, the availability of the data, the software, the platform, the ecosystem, the population parameters, all these things that are around the FAIR principle that all we know. So I would like to say, yes, about reproducibility, that we need to differentiate with this, something that is replicable, something is reusable, something is reproducible. So there are different meanings, there are different flavors of reproducibility, but I need to focus on scientific reproducibility.
Well, yeah. So this is, you know, maybe what I said indirectly, that you know, what I would like to see is people, you know, at the end of the day, focusing on maybe science and not, you know, yeah, just getting bogged down on these, you know, small differences in the results. But at the same time, you know, understanding, because, you know, to be able to say that, you know, your science is reproducible, God, this word, that, you know, your science is reproducible, you have to still understand, you know, what your software is doing, so that you can attribute, if there are any differences, you know, you first, you know, your first point usually is, if you get different results, if you follow, you know, exactly the same recipe for experiments, that, you know, every experiment that wants to be reproducible should provide, as you said, same data, same pipeline, same methodology. If you get different results, you know, you should, I think, understand where that difference comes from, and you know, in this case, you know, understanding what your software is doing, I think it's fairly crucial for understanding, you know, whether, you know, it's something wrong with the results, or there's something, you know, wrong with the software, and you know, you can only start thinking about, you know, science in this case, whether you broke the science, or there is something wrong with original approach or your approach, or maybe you've done something wrong in trying to reproduce the experiments, after you discard the sort of software the software component. But yeah, I agree that, you know, I think the scientific reproducibility is the sort of ultimate goal, and you know, that's what I'm trying to say here, that, you know, things like getting every, you know, as I said, as I keep on saying, exactly the same bitwise representation on every hardware, that should not really be of much of the concern, as long as it's not, you know, as long as you can live with, as long something as you can live with, but you should still understand, you know, how the software works. Right, I see there is a you know, lively discussion on Discord. If I miss some of the questions, I'm sorry, but there is a lot of going on, a lot of people writing, and I'm trying to keep up, I promise. So there is a lot of questions, a lot of the stuff about, you know, being able to run the source code and stuff like that. So we will talk about it in a second. So now you know, to point a finger at each and every one of us, you know, can reproducibility be optional? And I think the answer in the grand scheme is no, but just, you know, look deep down into your soul and think about, you know, when was the last time, you know, you've done one of these things of, you know, only you will use this code, or you will write the documentation later. You just want the code to work, and you're just gonna employ this quick hack for your code to work. All of these things, you know, really diminish the, in my opinion at least, diminish the scope and reproducibility and reusability of your code. So we've already talked about it briefly. You know, what are the tools for reproducibility? So, you know, I think starting on we were talking about, you know, okay, how and there is a lot of talk in the chat about different algorithms and you know, the sort of the bitwise representation. But what it comes all down to, as it was mentioned, that as we talked, you know, a couple of minutes ago, literally, that at the end of the day, you know, we should care about science, no matter what piece of code you write, or science that you enable with your piece of the code. So, you know, we need, you know, data, and we need algorithm of what to do with the data. And by the algorithm, I don't mean, you know, a computer algorithm, but the sort of methodology of what to do with the data. So no matter whether you're just designing the experiment or whether you're writing a software, you know, the really key starting point that I think is, I mean, I'm guilty of it myself, that is not given much thought, or is sort of, again, swept under the rug, is documentation. And as I said, well, it can be software documentation or methodology documentation. And then is the case of, you know, as I talked about, you know, from the point of view of software administrator, software manager, system administrator, and things that people already talked about in the Discord channel, that, you know, how can you care about software reproducibility or about science if you have to first spend, you know, 1 or 2 days of actually, you know, trying to compile your code or even make a code run if it's in a language that does not need compilation. And you know, we've got ways to help with that. You know, we've got things like containers, the containerization technologies. That's the one word that I said would be more difficult. Containerization. I always dread this word when I have to say it. You know, nowadays we've got consistent Python environments with Conda. You know, we can distribute notebooks, so we can kind of ensure, at least at the software level, you know, it's getting better. So you can kind of at least ensure, if you are careful, the sort of consistency of your environment. But on the highest level, and I think it might be one of the more difficult ones, is having a consistent and really consistent philosophy that is really set in stone, and you know, really put put reproducibility at the center, really, of a lot of software development. And again, you know, what we talk about, you know, within your team, decide what reproducibility means for you. Have, you know, metrics for reproducibility. Have, you know, sustainable, what I would call metrics for reproducibility, not things like, you know, we talked about, you know, have a good understanding of reproducibility, and one thing that I will talk about later, and you know, maybe that was connected to the talk about the bubbles. Understand what different parts of your processing chain do, and how they understand reproducibility, and how they approach to reproducibility will affect your results and your reproducibility. Right. So there is a couple of things. You know, are there any sacrifices that we have to make in terms of reproducibility? So you know, as I already said, if you know, start an experiment and you're usually on a tight budget, so maybe, you know, time is important for you because time is money. Maybe you don't have time to, you know, develop a coherent reproducibility strategy. Maybe you don't have time that, you know, it's being followed. In an ideal world, I could imagine, you know, every team or at least department having, you know, a person that is, you know, sort of high-level reproducibility champion, or within the team almost like a, you know, scrum master, having a reproducibility master. Do you have to, you know, change your work environment slightly? Does it have to adapt? You have to maybe use slightly less convenient programming languages or paradigms. And you know, what about legacy software that has not been written with reproducibility in mind? Can you afford to spend time to make it reproducible, to ensure that it is reproducible? Again, you know, on the most basic level, even going back to the software, writing documentation, fixing documentation, making sure it runs on a bigger proportion of the machines. It's mainly, can we afford that, both in terms of money and human resources? I think, you know, there's one thing that we talked about, that very often, you know, our teams, you know, in best case scenarios are small, and the worst case scenarios are very, very small. And you know, one thing we talked about, and there is a lot of chat going on, I think, about that, but it's something, again, yes, as was said, you know, scientific reproducibility, that is really the ultimate goal. So I wouldn't like to get bogged down on that. But, you know, portability, you know, there are a large number of available platforms. You know, you can have, as we said, differences even within the same generation. And as I said, going between CPU and a GPU, you can have a difference, or even, you know, on the same GPU, a CPU or GPU in the same architecture, you can have differences going between different GPUs. And I've, you know, speaking to people, you know, how they handle it. Some people say, okay, they just limit the number of available platforms. You know, those of you, hopefully most, that, you know, were using internet in the late 90s and early 2000 to mid 2000, it's sort of the equivalent of works the best in Internet Explorer in the resolution 1024.768. That sort of approach that limit the number of available platforms. But then my question is, can we actually call it reproducible then? You know, the idea is that, you know, basic idea of reproducibility would be, you know, you get the data, you provide the data, you provide this methodology of how to repeat the experiment, and you make sure that whoever wants to repeat it repeats it. And I think, you know, then by limiting the number of available platforms, that stands against the very, very core of what really means, what it really means for the science to be reproducible. Right, so now I understand that this is going to be a very controversial slide, and I'm expecting, you know, Discord to become red hot, and just just ground open up behind me and swallow me when I answer this question. So I understand I might become an unpopular person now, but I will ask this question. So it's not meant to it's mainly meant to provoke a discussion about, yeah, again, how we approach to reproducibility, and you know, very much connected to the slide of sacrifices in the name of reproducibility, and where we put reproducibility and sort of our development. So let me ask you, if we care about reproducibility so much, and when reproducibility in science is important, why do we use Python so much? And I can already imagine a lot of people asking, oh my God, what is this guy doing? But think about the last time you try running a piece of software, Python software, on a slightly different cluster, on a slightly different setup, and it didn't run, or it did run, and it gave you completely different results. And I understand, you know, this is not, you know, Python specific. I just put it as an example because for the last 8 months I've been working, you know, primarily and pretty much only in Python, and that's been cropping up, you know, pretty much every day. You know, famous example, print versus print is the least of your worries, you know, when moving from Python 2.x to Python 3.x. But, you know, it's common with a lot of other languages, you know, pretty much anything that uses external library or external module that is maintained not by a, you know, we could imagine core team, core consortium, that will be a problem. So, you know, you could almost replace Python with non-standard C++ libraries. So if you ever used Boost in C++, you will have the same problem, really. But I think, you know, Python is much more common. And the main thing is, you know, whenever we have nowadays new PhD students, new master students, new undergraduate students, I think Python is the first language that we teach. Very often, for a lot of people, it's the first time they ever write a program. It's in Python. So that brings me to a question: is, you know, how, if at all, do we teach reproducibility? Because, you know, I remember, or don't remember, being taught, as I said, in any of the, you know, programming context about you know, reproducibility. Maybe a bit in the lab, that, you know, in the physics lab, but never in the sense of software development. Yes, we've got someone.
Yay! Well,
Yeah.
I think this does touch on a point I was already making on Discord, right? I mean, it's sort of, how do we teach reproducibility, or how are we not taught reproducibility? Indeed, the answer from me would be, I've never been taught to be reproducible. Also, when I was when I still was a real astronomer, let's say, and it feels to me very much like I mean, I find reproducibility very important, and you know, I mean, I'm very passionate about the topic, and I'm very happy I see so much discussion on the Discord on it being found important by people. But it feels very much like there is not really an incentive from anybody to be reproducible as a scientist, because I think I've never met a scientist who has ever, well, okay, maybe I have ever met a scientist who has ever tried to reproduce anybody else's results. But I mean, it's not that people are so happy, like, hey, look how cool I am. You know what my career is about? It's reproducing other people's work.
I I think you touched on a very important subject here, that for a lot of people, you know, yeah, I think if people do it, they do it, you know, maybe in their spare time, or to hope maybe, you know, that they try to repeat some experiment in the hope that they won't be able to do it, and they will be able to publish a rebuttal paper. You know, I think it mainly comes back to the point that, yeah, you don't see papers that, because, you know, a lot of it in science world and academia is about, you know, how much papers you can publish, and how much you know, how much exposure you get from your research. That there is no, yeah, as Jose said, and you said, and what I wanted to say, that there is no incentive to run reproducible research, and you know, because a lot of the time, okay, there are certain experiments that, you know, you can do within your spare time, you can reproduce them, but how, for example, you go around reproducing a result of a simulation that took, you know, months to run on a supercomputer. You know, I don't see any funding body providing, you know, tens of thousands of pounds to run a supercomputer for 6 months just to prove that someone's result was correct again. And you know, you can't publish, in this case, a paper saying, okay, we run it again. Yes, our results agree with what this previous paper published, because, you know, papers like that were accepted, you know, in the 1900s or early or late 1800s. Well, sorry, late 1900s and early 2000, you know, 19th century, early 19th century, but not anymore. So yeah, I think that this is the problem, that you know, you don't really have scientists that say, okay, I just try to reproduce everyone's research in my spare time. It's a lot of the time, it's mainly that, you know, when they see something controversial, and mainly come already pretty much from the conclusion that they're going to prove that, you know, something went wrong and something is really wrong.
But Mateusz, isn't that then the task of the peer review, right? To a certain extent, of course, we need to cap that, because not every peer review can have that multi-million euro cluster at their disposal. So shouldn't the peer review guarantee that we can reproduce the scientific results presented in the article or in the paper? I mean, that is what the peer review is for, right? That we have a scientific sound article, that the results are reproducible, and that the other peers can rely on what is said in the paper, because that is the foundation of the citation system.
Yeah.
Right? I mean, if that is not happening, then yeah, what the hell? I mean, the whole thing doesn't work.
Yeah, I agree, but then again, it's you know, the peer review is done by you know, human beings, and again, as Jan said, you know, with limited amount of time, and doing other things, you know, focusing on their own research. So, you know, how willing would someone be to, you know, how to ensure to you know, work on someone else's really research just to ensure that it's correct.
Yeah, but what's then the point of the peer review? Sorry, what's the point? The gatekeeper to not let a citizen scientists in? Come on.
Yeah, no, I really agree with you that it should be, you know, really. I would personally see this as a core thing of peer review, you know, making sure that results make sense. It's just, you know, we do have to, I think, recognize that in certain situations it can be difficult, you know. As I said, let's go back to this, you know, the 6 months running simulation, what would be your, expectation of peer review? Yes, the results make sense, but you would not expect them to run the simulation all over again because they can't do it. So in this case, then the definition of reproducible might change, because results scientifically make sense, they are sound, but you have to remove this sort of reproducibility from point of view of running the software and making sure that software, when you run again, that it provides the same result. I think it's a very complex thing in this case in terms of in terms of the peer review, and I think we could discuss it much more in
another BOF.
Because you could pretty much have a whole separate BOF, to be honest. In this case, maybe for next year, the role of peer review and in science, and in reviewing not only scientific papers, but also what would be the role of peer review in reviewing software papers, that we see more and more journals are accepting them. Can we implement the same standards, or should we have extra standards for reviewing those, whether they make sense not only from algorithmic point of view, but can that do what is their reproducibility potential? I see there's Vladimir has been hanging around for a while. Vladimir.
Oh, thank you. I was just listening in. I just wanted to chime in with some points and maybe opinions.
Yeah, of course, of course.
But first, I want to comment you on the slides that I see right now on Zoom, because that does reflect many of my own convictions in the subject. I have various experience with making software reproducible to a certain degree, and in fact, I actually like to do it as part of the process. When I finish another iteration of my code, I actually try to run it, and then I want to see what changes. And the kind of things that I'm doing are complicated enough. It's a multi-threaded code that is optimized for speed and all that. Naively, I would have expected it to have different results every time I run, simply because when you add floating points in different numbers in different order, you're going to get things that end up varying with the last digits. And the things I always keep being surprised by is that by and large, that actually doesn't happen. But what I do see all the time is that even for like very simple C software, the places where it gets loaded, the amount of memory it uses, how quickly it runs, that all changes all the time. And so the question of making the software to be, say, bit by bit reproducible is a really tricky business. One experience that I have, that I know of, that not personally, but through another person who described it to me, is that they were developing a computer game for tablets. And the idea was it would be multi-user game where people would go and play. And because it's a networking game, they don't want to transmit all the states. They thought they had a bright idea to only transmit the player moves, which is when they very quickly figured out that you can transmit the player moves, and then players will actually end up in different places on each of their screens, because the software will actually aggregate those moves in a slightly different manner. And when they started trying to make it reproducible, it turned out it was not just a matter of coding practices or like test cases or not, but it's actually algorithms. There are some algorithms that work, some don't. Different CPUs on the same Intel computer, you might use AVX or you might use FPU. You'll actually get different results. If you have a big cluster, you would have a problem that we have these things called cosmic rays. They strike the bits, they flip them. you will actually end up with results that are flipped. You will end up with bit rot in your code and your data. On a big cluster, I often have a situation where if I simply run the software and blindly trust the result, I would actually have a certain fraction of corrupted data back. I have hash some checks that are being computed while the software is running to actually let me know what's going on. And so from this point of view, it's not just the issue of other people trusting it, but of you actually keeping control of what your code is doing. So it is important. But on the other hand, I also view it from a statistical viewpoint. So if I produce results that I'm saying, say, 95% confidence level, then if I have 0.1% of stuff being non-reproducible, it's really within the tolerance that I have. And so that's fine. And perhaps the best way to reproduce results would be to observe them with something else. If you have a radio telescope result being confirmed with an optical telescope, this is like the ultimate reproducibility because everything is different. So I think this is, it's important to focus on your software being correct and reproducible in this way. But we also shouldn't lose focus of the fact that underneath all of that is physics, right? Physics, astronomy, actual real stuff. And that is actual reproducibility. And there is all kinds of really interesting things happen that really have to do with physics.
So that's a great point. Thank you. I don't know who is next. Susanna, I think.
Hi, thanks.
Welcome back.
I would like to come back to the peer review, the review process a moment, because something that I think we need to think about is that we need to develop tools to support this process. So we are not in an era in which the data sets are huge. We need to access to distributed computing infrastructure to run the software, to access the data. And we need to be able that the reviewers of our scientific experiment can access to all these environment in order to verify our results. And this is very important, and is related to what I mentioned before, that the availability of the method is not just that they are publishing somewhere, but that is easy to use the data, to run the software, etc. And this is something that we need to pay attention now, that this software is not running anymore in your laptop or in your computer, but in remote computing centers that you need to a login and a password to run the software. You don't know where is the data. All these things that even for the people working in the collaboration is difficult. Even more difficult is for the reviewer. And this difficult a lot the reviewing process. So we need to focus also. I think we need to pay attention on that. So
I do agree with you, absolutely. And I think, as I said at the very beginning, I think we see that in many BOF sessions, that is that are here, that we do take it seriously. How it's like 2-3 BOF sessions about standardizing data formats, archiving, and things like that. So yeah, I think that's the key. We did spend a lot of time talking on this sort of what I would call a low level reproducibility, but the starting point, as I said, is this sort of high level. When I said, you would almost put it under the documentation / methodology that, you make data accessible and you make software accessible. Just, that's the first really point where you really start thinking about reproducibility, making data and software available and easy to run. And that's, what I think, things like, containers, the things that I listed a couple of slides ago, containers, notebooks, come into play. But yeah, as you said, and stuff that is very often neglected, access to the data, because that also costs money. But that question is asked, very, very, very often. How can I get the data? Oh, it's behind this VPN, behind this SSH, and you have to go through these many login nodes to get the data, and it's not accessible anywhere easily, as you said. Sometimes, people within the team have problems with either accessing the data or running the software. So how can we expect someone outside the team to be able to rerun experiment and get some useful insight if we within our team we cannot guarantee that? And I think that goes back to what I said at the again a few slides ago, the philosophy, really, the changing approach of, we not, maybe to use the nomenclature from yesterday's book, that we are not in our own bubble, not only bubble of software engineering or scientists. Within a group, we're not in our own bubble. We have to make sure that other people can use our research and can reproduce it and can question it, because as you said, this is a cornerstone of science. So I think we should start really before we go on to looking how floating point numbers are treated on CPUs and stuff. This is what I tried to say at the beginning. This didn't really be. We did spend a lot of time talking about it, and I think agreeing in a lot of cases that that's not the exact focus on reproducibility. It's what you say that should be really the end goal, and everything else is really the means to achieving it.
Other comment related with that is that maybe we need to think about in which kind of metrics we think that could be useful to incentive reproducibility, because we know it's true there is no incentive at all, as Pepe Salter said in the chat a long ago. But I think the tendency is changing now. In the Europe, there is some rules in order to incentive this kind of the openness of the data and the methods. So we all know that the tendency is changing.
Yeah.
But now that this is changing, we need to think that, okay, what is the best metric to evaluate how reproducible is a scientific method or scientific experiment? Because all can we agree that the availability of the data and software is the first step, but maybe this is not enough. Yeah, no,
I think it's not enough. In my opinion, it's definitely not enough. But it's an important first step that we should all take, because unfortunately it's an important first step, but it's still lacking. It's a first step that many research groups and institutes have not taken. And as you've said, I think if not by asking, is by forcing research groups to do it, because a lot of I see more and more funding bodies. They add, the data accessibility or even software accessibility they are adding as a requirement for, funding reviews and things like that. Of course, there is still a question of, you've got a proprietary data, your data is protected for X months before you have to publicly release it. But I think, one way is really, and that's really on funding bodies in this case, ensuring, enforcing the fact that the data is and software and the methodologies are released, and not only brief mention at the end of web version of your science publication, but somewhere that is easily accessible and pretty much step by step reproducible, almost example. Yeah, but I do agree. I do agree with the things that you said. I think we've got someone else waiting. to speak. So thank you, Susanna. I think we can talk about it later. We've got someone else waiting. So sorry to keep you waiting. Hello. I've heard something for a moment.
It's Enrique. I can try to ask him to unmute.
Yeah.
Can you hear me?
Oh, I can do that as well.
Yeah.
Hello,
Okay. Enrique. Yeah.
Hi, somehow I was unmuted all the time. Okay, so I just wanted to mention something very similar to what Susanna said. No,
We hear you, Enrique. There is some background for me in the background, so my neighbor is drilling holes, but we hear you. Please speak. Yeah.
Okay, so going on the lines of peer review and how reviewers can reproduce the results. No, I think we should enable tools that allow to somehow ease the task of reproducing results, right? So imagine that, I know, something like you have results in your paper, let's say a graph, for instance, and attached to each of these results, there is a unique identifier that will give you some workflow, some way to basically reproduce the data, so that basically the task of reproducing will be as much automatized as possible. Of course, this leaves many questions also, no? As Susanna said, the fact that you can see how this was done doesn't mean that you have the resources, computer resources, or things like that. No, so there are many questions still to ask. No, but I think the automation of reproducibility will be a good step forward to allow that.
Yeah.
And on a different topic.
Definitely.
Yeah, on a different topic, containers are mentioned here. The containers are used in two different links of the chain. They're used by the final users, and for that I think might be a good way to say, okay, I know that this is the container that was used to certify that something was working in some way, so I want to use that to reproduce the result. But if it's abused in the other extreme of the link, basically by the developers who say, okay, this is the container in which we have tested everything, I think that can be dangerous. I think this has been also posted in the chat, in the sense that if I'm not able to reproduce my results in anywhere else, and I just say, okay, this is the container in which I certify my results, that is suspicious. I mean,
yes, well,
if you're vertical, if you are only able to reproduce the results in a vertical stack and not with some variations of it, that's fishy, I would say. So
yes.
this is a little bit dangerous to say, to rely fully on a container which maybe you keep unupdated for 10 years, and you say, oh, this is the only way actually you have to reproduce the results. If you are not having more moving parts basically under the hood and verifying that these moving parts don't change your results, then you can have little confidence that actually you're making a mistake, and just by chance basically with your vertical stack you are able to see the results, the proper results.
Yeah, I think, you know, it's I think it's going to be on my last slide. It goes back to the thing of, you know, understanding, maybe not domain specific knowledge, having domain specific knowledge, but understanding the tools that you're using and understanding the limits and understanding still what you can trust. Yeah, one thing is, yeah, containers have been, you know, on the market really for X years, very popular for the past X divided by 2 years. And a lot of the stuff that they enable is A, misunderstood, and B, as you said, is definitely abused. There are these problems of like, oh, if you want to reproduce my results, just run my container, and that should just give you all the stuff that you need. That, yes, as you said, on one hand it is, you know, convenient. It is, you know, that's what I said, you know, from a sort of software manager or system administrator point of view, they enable reproducibility in the sense that you are able to provide a consistent, you know, working environment to someone, but yes, there is definitely scope for abuse, and one has to be careful, especially as you said, when there are stale Dockers, stale images that worked once 10 years ago. Well, Docker won't have Docker working 10 years ago, since it was introduced in 2013. But yeah, Docker that worked in 2013, and since then everything changed. The Docker engine changed, and since then, even with the same stack, you cannot reproduce it. So yeah, there is a healthy dose of skepticism that we should I think apply to everything. So that's a very good point. Right, we're gonna we've got 2 people still waiting. So I think it will be our last 2 sort of vocal contributions, because we sort of very short on time. We're pretty much out of time. So let's see, Peter.
Yes, thank you. Can you hear me?
Yes, I can hear you very well. Yeah.
So great. I was really surprised. Thank you for organizing this. I mean, it's a topic dear to my heart, but what I hadn't realized is that your BOF is really the summary of why we are at ADAS. We all strive to write software that does the right scientific thing. We hide it in the BOF and called reproducibility, but and there's many ways how we could deviate from the path, and that's why we're here. We want to stay straight on the path. So I really like this BOF in that sense, that this really summarizes why we're at ADAS.
So what you're saying is, if someone was meant to attend just one talk in the ADAS, is this talk?
Well,
no,
I think
I'm joking.
Most of us have seen all these ways how we can deviate from the path, and
yes,
there's a lot of comments in the BOF that talk about that, and I really enjoyed that.
Yeah, no, I mean, this is what I said at the beginning. A lot of these talks and a lot of other BOF sessions, they do talk about things how we can achieve reproducibility, as you said, without attaching the word reproducibility to it. So as I think I mentioned at the beginning, sort of like an umbrella talk.
I'm just stating the obvious.
Yeah, it's like practical provenance, and it came up many times over the last hour and a half. How to, even simple things of how to provide the data to someone as a good first step to reproducibility. So I'm glad that you enjoyed this, and that was sort of my sort of plan to provide sort of like an umbrella sort of term and an umbrella maybe topic to combine many things. I see Dirk waiting here patiently. So that would be, I'm afraid that the last contribution, because as I said, I don't want to keep everyone waiting for meeting their breakfast and or slash their lunch slash dinner. So please, hello.
Yeah, can you hear me?
Yes, I can hear you.
I just wanted to echo part of the discussion in the Discord. The requiring a bitwise reproducibility is, I think, really difficult, even for the own group. If you think of algorithms that have sort of random initial conditions, Monte Carlo things and so on.
Yeah, I've seen someone mention that the Monte Carlo submission, by a pure definition, it's, well.
Yeah, so there has to be some margin, but I think the important part is that one describes the method to arrive at a result in enough detail that you can reproduce it yourself with the same or different algorithm, and more importantly, other groups have enough information from your publication that they can try to do the same thing, the same algorithm, but with a different implementation. And obviously this will lead to a result that is not bitwise comparable, but it should get to the same overall result.
Yeah.
It's probably difficult to describe what does it mean to have the same result. So what is the margin really? But I think this is the basis of science, that others can reproduce or maybe not your result.
Yeah. So I don't know how many participants are there in this BOF, and I was able to hear only few of you and see only few of you contributing in the channel, in the Discord. But I think the general conclusion is sort of the same. I showed this this sort of the bitwise reproducibility as an extreme example, and I said at the pretty much beginning that, in my opinion, this is not what really counts as a reproducibility. But as I said, I wanted to provide it as an example that some people that I've spoken to, they see reproducibility like that, and I'm glad that a lot of us, the conclusion is that this is not really how reproducibility should be approached. This should not be at the core of reproducibility. But I think it's still for us to communicate it better, and I think the problem is that there isn't a clear definition of what a reproducibility might mean for us and for other groups. But I'm glad that we from the people at least that had a chance to talk to or read on Discord, that we kind of come to the agreement that this is not something to expect from reproducibility. Okay, thank you very much. So now the last slide. We talked about this state where we are, and where are we going? Where are we going now? Currently, I think we're in the state that I think was mentioned, that currently still in terms of funding is reproducibility is welcome by scientific community, but in terms of when you look at funding, it is optional. So I think one of the things is is kind of tying reproducibility to funding as a requirement. We've seen sharing our code widely through consistent software deployments, notebooks, containers, but as I was mentioned as well, there is a scope for trusting these way too much and abusing them. But we are getting processing and pipelines are getting more and more complex, and it's hard to keep track of relevant changes in all levels. And a lot of stuff is currently, to be a modern scientist, the traditional astronomer, you still have to understand how code works and stuff like that. Where should we go? There's a concept that I've borrowed from web developer. I call it full stack of reproducibility. And again, maybe it's not for everyone to be as full stack reproducibility, I don't know, full stack reproducible scientist. To sort of have like a reproducibility champion, if not in a group, but in the department person, that knows how different steps approach and influence reproducibility. But even you as a scientist, I don't expect you to know exactly how a piece of software works, or how cosmic rays bump your bits in the memory and how that influence bits in memory exactly, but sort of be aware of maybe back to yesterday's both, be aware of other bubbles and what other bubbles are doing. And back to Python or C++ compilers and libraries, can we as a scientist have influence on language developers on how the libraries are developed? We've had great talks with AstroPy that we as scientists contribute to that and have real influence on that. But can we as large group of scientists, can we actually have influence on other libraries that are not purely science-based, like as I've mentioned, Boost libraries or C++ standard libraries? And mentioned many times, which I'm very happy, can we create some set of reproducibility benchmarks or test suits for our reproducibility.
Folks, please wrap up, because I got to do a bunch of stuff for the next webinar.
And that's all. And I've wrapped up. Thank you very much. No, that's all I had to say. So I think it was very useful. I mean, a lot of different incomes, and I think I think the conclusion is that the reproducibility is dear to all of us, and we all care about reproducibility. I think now it's just the time. It's a great time. We've got the tools, really, you know, with sharing the data, sharing our software, sharing our methodologies. It's starting to really, I think it's now the time. We've got the tools. It's time to start implementing it on the large scale. Thank you very much. That whale should not have been there. It just happens when you reuse slides. So thank you very much, and I hope the fruitful discussion continues on Discord. If you want to reach me, feel free to reach me on Discord or through email. I'm always happy to chat about reproducibility. If you want to work together, I'm really happy to get involved in some initiatives that people might have in mind. Thank you.
Okay, thank you very much.